right, I'm now going to walk through the 2018 AP Calc AB free response question number 5. So this is also a no calculator question, and let's just dive right in. So number 5 says, let f be the function defined by f of x is e to the x times cosine x. Part A, find the average rate of change of f on the interval from 0 to pi. Okay, so notice this says average rate of change, not average value. Those are different. So for average rate of change, we're just looking for the slope between the endpoints of this interval from 0 to pi. So in other words, we just want to know, so the average rate of change is going to be this slope. So remember, slope is rise over run. So our change in y value is going to be from f of pi to f of 0. And on our x's, we have pi minus 0. So f of pi is e to the pi cosine pi minus f of 0, e to the 0 cosine 0, all over pi. So now, thinking about cosine, I always go back to the unit circle. So here's my poorly drawn unit circle. Remember, cosine is the x-coordinate of points on the unit circle. So at 0, our cosine is the x-coordinate, which is 1. And at pi, our cosine is the x-coordinate, negative 1. So that means I've got negative e to the pi minus e to the 0 is just 1. So minus 1 over pi. And that's my answer. That's it. Part B says, find the slope of the line tangent to the graph of f at x equals 3 pi over 2. Here, we just need to remember that the slope of the tangent line at a point is exactly the derivative. So we're trying to find f prime of 3 pi over 2. To do that, we first need to find the derivative. So f prime of x is going to be the derivative of f, which is this e to the x cosine x. We have a product of two functions, so we need to use the product rule. So that is 1d2. So derivative of cosine is negative sine plus 2d1, so cosine x. And the derivative of e to the x is just itself, so it's e to the x. And we want to evaluate this at 3 pi over 2. So at 3 pi over 2, we have, let's see, we've got e to the 3 pi over 2. I'm going to factor that out. Times, we've got a cosine 3 pi over 2 minus sine of 3 pi over 2. Again, going back to my unit circle, 3 pi over 2 is right here. I need the sine and cosine. So the cosine, this, you just need to figure out the x and y coordinates, right? The x coordinate is 0, so cosine 0. And the sine is negative 1. So this is cosine 0, sine negative 1. Cosine is 0, sine is negative 1. So we have minus the negative 1, which is plus 1. So we just have e to the 3 pi over 2. That's our answer. Okay. Part C says find the absolute minimum value of f on the interval from 0 to 2 pi and justify. Notice here they're not saying to find the x value where the minimum occurs. They want us to find the actual minimum value, which will be the value of the function f at that point. So first we need to find the x-coordinate where the minimum occurs, and then we need to find what that actual minimum value is. And now this is an instance where, since f is a continuous function, I know f is continuous and it's differentiable because it's just the product of two continuous and differentiable functions, e to the x and cosine x. If I want to find its absolute max or mins, remember those can occur at either the endpoints of my interval or at relative maxes or mins, which are, well, I guess in this case we're just thinking about a min, so a relative min. And remember, a relative min is a critical point. So what I'd recommend doing here is first finding all the critical points. So, well, we just found the derivative above. Remember, we have that derivative is e to the x cosine x minus sine x. And so if I want to find the critical points, I want to know where this is 0. And now it's good to remember that e to the x is never 0. In fact, it's always positive. You can see this by looking at its graph. Its graph is always positive. So we could divide by e to the x on both sides. It's never 0. So this is only going to be 0 if cosine x minus sine x is 0, which would say that cosine x has to be equal to sine x. And now at this point you have a couple options for how to solve this. I'm going to show you the way that I like to do it, which you've maybe never seen before, but bear with me, I think it's helpful. So again, when we're looking at the unit circle, remember our cosine is the x-coordinate and sine is the y-coordinate, right? So if I rewrote this in terms of, say, an angle theta, just to not confuse my variables, I want to know where the x-coordinate, the cosine of the angle, is the same as the y-coordinate. But this line, this is a line y equals x, and I can also draw that. So the line y equals x happens, is this line. And the points then that I'm looking for are the places where this line hits the unit circle. Those are my angles. And what are those angles? Well, this is exactly pi over 4. And this is, let's see, pi plus pi over 4 or 5 pi over 4. Well, to get all the way from here. So backing up to what I was calling x before I switched to thetas, this says that our x coordinates here, our critical points, are at pi over 4 and 5 pi over 4. Okay, and so those could be relative mins, either of those, or relative maxes. They're critical points, so they could be any of those. And so this absolute minimum value has to occur at either pi over 4, 5 pi over 4, or one of the endpoints, 0 or 2 pi. So I'm going to make a little table to test my values for x and for f of x and see which of those gives me the smallest value for the function. So we have 0, pi over 4, 5 pi over 4, and 2 pi are our possible, some people call this the candidate test. These are our candidates for the absolute minimum. And then we want to find the value of the function there, not the derivative, the value of the function, because we're finding the minimum value of f. Okay, so at 0, I think we already calculated that to be 1. Yeah, that's just 1. At pi over 4, we're going to have e to the pi over 4 cosine of pi over 4. Cosine of pi over 4 is square root 2 over 2. So this is square root 2 over 2 e to the pi over 4. At 5 pi over 4, the cosine is negative root 2 over 2. So that'll be negative root 2 over 2 e to the 5 pi over 4. And at 2 pi, cosine is 1 again. So this will be e to the 2 pi. So where is this function the smallest? Well, at the only negative one. That must be where it's lowest. So this has to be its absolute minimum value. So just rewriting that, that's negative square root 2 over 2 e to the 5 pi over 4 is the absolute minimum value. That's our answer. Okay, part D says let g be a differentiable function such that, so this is a new function and it's differentiable, and g of pi over 2 is 0. The graph of g prime, the derivative of g is shown below. Find the value of this limit or state that it does not exist. Okay, so whenever you're given a limit, the first thing you should try to do is you should try to just plug in the point, because if both the top and the bottom are continuous there, then if you get a number by just plugging it in, then that's the answer. So trying to plug this in, we would get f of pi over 2 over g of pi over 2. Notice they tell us that g of pi over 2 is 0, and f of pi over 2, that's e to the pi over 2 times cosine of pi over 2. But cosine of pi over 2 is 0, so that's 0 also. Alright, so now we realize we're in a 0 over 0 situation, which should indicate to us that we should do L'Hopital. One caveat to be able to do L'Hopital is that both the functions on top and bottom have to be differentiable. But they are, since f is differentiable, we established that earlier, and g is differentiable because they tell us it is. Okay, so now this original limit, as x goes to pi over 2, of f of x over g of x, by L'Hopital's rule, so you might want to say, by L'Hopital's, I always forget how to spell it. This limit is the same as the limit as x goes to pi over 2 of the derivative of f and the derivative of g. And now I do the same thing. If I try to plug it in, what's the derivative of f at pi over 2? Well, the derivative of f at pi over 2, that's going to be the e to the pi over 2 times, I believe it was cosine pi over 2 minus sine of pi over 2. Cosine of pi over 2 is 0, sine of pi over 2 is 1. So on the top, we've just got negative e to the pi over 2. And now what's the limit as g prime goes to pi over 2? G prime of pi over 2 has a limit. And it looks like, because this is the graph of g prime, it looks like that limit is 2. So we get this over 2. And that is our answer. Okay, and that's it for problem number 5.
Guys, don't forget to subscribe and hit that bell for all future notifications.